we have, it's a typical examination question. And then they say in the diagram, we have the vertices of A, B, and C are vertices of a triangle. And then they say E is a point such that AC is perpendicular to EB. So we have AC, which is perpendicular to EB. And then they say we have point D, which lies on BE. Like they just said D lies on BE. It's not a midpoint. Okay? We're not going to assume which is a midpoint unless we are told which is a midpoint. And then they say which we have the equation of the line BC. So this line here, they gave it its equation. The equation of this line, it says which is 4y, and then minus 5x, and then it says which is minus 30, which is going to be equivalent to 0. Now, we can get the gradient. We can get the gradient of this line, BC. Now, if they ask us to get the gradient of line BC, we'll have to put this equation here in a standard form. So if they gave you an equation not in a standard form, they can ask you to get the gradient of line BC. I know they didn't ask that, but I wanted us to start with that to say, how would I know what is the gradient of this line? They didn't say anything about the gradient again. Now, how do you get the gradient? The gradient, you need to put this thing here in a standard form. What is the standard form of this thing? Standard form of this thing, it says y is equal to mx plus c. That's very important. So in other words, it means which one the goal here is to make sure that you make y the subject of the formula. Okay, let's do that. I'm going to do it. You want to divide by 4 first? Okay, Matebula is saying he's going to divide by 4. So he's going to have 4y minus 5x minus 8, which is going to be equal to 0. And then you say you divide by 4, you divide by 4, you divide by 4. Okay? And then it says which y. If you say 4 and 4, they are going to divide each other out. Okay? And this one we're going to leave it as a fraction. So we're going to have minus 5 all over 4x. And then if you say this one and this one, it gives us minus. It's minus 15 all over 2, which is equivalent to 0. Still, Matebula, it's okay. I can say now I have y, but I don't have y as the subject. I want y to be the subject. You say I should say y is equivalent to
85 over 4.
So you take this one to this other side. Okay, so you have 5 all over 4x, yeah?
5 over 4x.
Yeah. Plus 15 all over what? All over 2. Okay, now look at this here, guys. So as you can see, this equation and this equation, I just want to take this equation and put it here. I get this one, like it's y, it's mx plus c, okay? Now let's play this trick here so that you can see. Okay, this one and this one, be the same person again. And then this one and this one, be the same person again. And then this one, obvious, and this one, shooting in a body as what? The same person. In other words, what that means is we can then say, even these two people, you see this one and this one, they are what? They are the same person. So in other words, what is going to be our m here? If they ask us which one is m? 5 all over 4. Yeah, like that. Typical examination question. They say calculate the gradient of PT. Let's go and check. Do we know what are the coordinates of T? Do we know what are the coordinates of T? So it means for 3.1, we'll say 3.1, we have m, which is going to be given by y2 minus y1 all over x2 minus x1. Okay? Now, which coordinates are we going to look at? We're going to look at the coordinates of P and what and T. Then, alphabetical, if we do it alphabetical, which one is going to be x1?
Minus 14.
Minus 14. So we can come and say, okay, if we do this thing alphabetically, we can call this one x1, and then we'll call this one y1. And then we'll call this one x2, this one y2. And then when we go into this, we're going to have y2. According to this, what is our y2? Minus 4. Okay? Minus open bracket. What is going to be our y1? It's minus 10. Close bracket all over. What is our x2 based on what we chose here? It's minus 8 minus open bracket. What is our y1? Minus 14 again. Now you take out your calculator, and then this is how you're going to type it on your calculator. You say fraction again. And then you say minus 4, minus, and then you need to open a bracket, and then you have minus 10, close bracket, and then you have minus 8, minus minus 14, close bracket. And then if you say equals to, it says which our gradient is going to be equal to 1. Now, how are we going to mark this thing here? We're going to say 1 mark for substitution and then 1 mark for the answer. So if this was an examination, we have 2 marks. Instead of getting 0, we have 2 at least. The next question says, okay, write down the gradient of AC. We want to know what is going to be the gradient of AC. Let's come and check now. Do we know what are the coordinates of A? Do we know what are the coordinates of C? We don't know the coordinates of C again. And then it's not a mistake. They don't want the coordinates of C. If they're asking you about the gradient of AC without asking you C first, it means we don't need C to calculate the gradient. How are we going to get then the gradient of this thing here? That's the question then. How would we get the gradient? Now let's look at the line that we just calculated. It's AP again. Now AP and AC, what kind of relation do they have? Let's come and ask ourselves that question. What kind of relation do they have, those two?
Parallel.
A. Yeah, if we check EP here, EP and AC, what kind of relation do they have? They're perpendicular to each other. Okay? Now, what do you know about perpendicular lines? So if we multiply their gradients, they're going to give us what? Minus 1. So I would say that in other words, it means for me to get 3.2, I will say M of, this one we're calculating PT. So I'll say M of PT. The M of PT multiplied by the M of AC, they're going to give me minus 1. Is that clear? Now, remember, we know what is the M of PT. Eh? What is the M of PT?
1.
What is the M of PT?
1.
The M of PT is 1 again. Multiplied by M of AC. Now we want to get AC here. How would you get AC here? We divide both sides by 1 again. And then if we divide both sides by 1, we divide both sides by 1. It says which therefore the M of AC is going to be equal to what? Minus 1. And then for you to do something like this, we'll give you 1 mark. Oh, we'll give you 2 marks. Yeah. Now, another way you could have done this thing, you could have said here straight from here. You say M of AC is equal to minus 1. And then when they ask you why are we saying that, you could have said which give them you give them the answer, then you give them a reason. You don't show all the steps. Agree? You see here, I show the steps again. You can give them the answer, and then after giving them the answer and tell them which AC is perpendicular to BE. Okay, we are going to the next one here, which is 3.3. What are we doing on 3.3? On 3.3, they say which we should give them the equation of like. So they say which we should calculate the equation of line AC. As we're saying, line AC, we know what is the gradient, okay? And then but we have 1 point. So if we have a gradient and 1 point, then we are good to go. And then we are saying we should use y is equal to, we know what is our m again. So we're going to use this equation that says y is equal to mx plus c. But we know what is m. So instead of m here, we'll put whatever m is. So m is equal to minus 1 again. And then the only point that we can use is going to be this one here. So if we use that point, we're going to say to them, according to this point, it says which y is, what is our y? It's minus 1 is going to be equal to minus 1 multiplied by 4 plus c. Again. And then if you say minus 1 is going to be equal to minus 4 plus c. You take this 4 to this other side, it says which you are going to have a 3, which is going to be equal to what? To c. And then it says which therefore our equation is going to be given as y is equal to minus x plus 3. Yeah, and then for this one, it's going to be 3 marks. We're going to give you a mark for substituting, getting C, and then the equation. All right, then we go to 3.4. 3.4, they say which we have G, which lies on line AP. So go and look for line AP. So you have line AP, and then we have G. They say G lies somewhere here. We don't know where because one thing that we know the y value. The y value is equal to -5. Okay? So if I had to guess, say this one is -10, I expect it to be somewhere there in the middle. No, not necessarily in the middle. I should be careful here. I expect it to be somewhere here. So I'll say, okay, my G is going to be something like this. I have P. I have P is equal to what? To -5. And then they say which G lies on this point. Okay? So if P lies on that point, we want to get P. That's what we're interested in. We want to get what? We want to get P. So how then will we get our P? We're going to get our P by using the fact that the gradient of BG and the gradient of AB are exactly equal because these points, they are collinear. They lie all on the same straight line. Like if I knew what was the equation of this line here, I would have used the equation of that line, but I don't know what is the equation of this line. I think they gave me the line, the equation of line BC. They didn't give me the equation of line AB. So I'm saying to you, how am I going to do this? I'm going to do it this way. I can calculate the gradient of AB. How do I know which I can calculate the gradient of AB? I can calculate the gradient of AB because I know what are the coordinates of A, I know what are the coordinates of B. So let me start by doing that. First thing that I'm going to do here in 3.2, I will say, okay, let's go to 3.2. Now on 3.2, we are going to say we have B and then we have A. The strategy that we're going to use here is as follows. We know the gradient of AB. Look at this. We know the gradient of AB. So I'll say the M of AB is going to be given by y2 minus y1 all over x2 minus x1. Okay? Now then I choose which one is A, which by now we know how to do that. Okay? If we do it alphabetical, what is going to be our y2 here?
-10.
-10. Okay. Minus open bracket. What is going to be our y1? It's -1. Close bracket all over. What is going to be my x2? -14. -14. Minus open bracket. -4. Or 4 only. Okay, it's not -4, it's 4. Okay, if we type this in our calculator, then it says what do we have? It says which we have 1/2. So we'll come and write it with this one here, it's 1/2. Good for us, we're done with that one. Then the other thing that we're going to do is that we are going to look for a gradient BG, or we are going to look for a gradient AG. It's up to you which one you want to get. Now, the gradient, let's take the gradient of BG. So I'm going to look for M of BG. If I look for the M of BG, look at what's going to happen here. I'm going to tell them what I have y2 minus y1 all over x2 minus what? X1. Now, do it alphabetical again. Let's do it alphabetical. What do you know? You know which one is y2 here, based on this, based on what, if we do it alphabetical, what is going to be y2?
Minus.
So we're going to say -5 minus open bracket. What is going to be our y1? Minus 10. Okay. All over x2, alphabetical. This is going to be P again. Minus open bracket. What is going to be our -14? Oops. So we have -14. Now, here's what I'm saying. I'm saying to you, because these things, they all lie on the same straight line. Just like you can use parallel lines, just like you can use perpendicular lines. Then you can say to them, okay, the M of AB is going to be equivalent to the M of BG. Why am I saying which these two gradients are going to be equal? It's because the points, all of them, they lie on the same straight line. That is why they said the point B, it lies on AP. That's what they were trying to tell you. It's collinear. They all lie on the same straight line. Meaning, in other words, instead of writing this thing here as M of BG, I know what is M of BG. I know the gradient. What is going to be the gradient of this thing here? So here I'm going to say this thing here is 1/2. If this is 1/2, then it becomes simple now. It makes my job to be a little bit simple. I want to solve for P again. If you want to solve for P here, what are you going to do? You want to make P the subject. How are you going to make P the subject? You cross multiply. If you cross multiply, this thing here is going to give you this one multiplied by this. Okay, maybe let's simplify this thing first before we cross multiply. If we simplify this thing here, it says which we are going to have 1/2, which is going to be equal to minus 5, okay? Negative and negative, it gives us what? Plus 10. And then if you type this in your calculator, it's going to give you positive 5, okay? Yeah, if you type this in your calculator, it's going to give you positive 5. So you say you have 5 here. All over. Here you have negative and a negative. If you have a negative and a negative, it's going to give you P plus 14. You are still good there. And then from here, you cross multiply. If you cross multiply, here's what you're going to have. You're going to have this one multiplied by this one, okay? And then it says which you have P plus 14, which is going to be equaling this one multiplied by this one, which gives us what? This one multiplied by this one, it gives us 10. And then you take this one to this other side, it's positive, okay? If it goes to that other side, it's going to become what? Then it says which P is going to be equaling to minus 4. Does it make sense for P to be minus 4 here? Does it make sense for X to be negative? Let's check there. It makes sense, okay? Yeah, our X can be negative. Then it means which our P is going to go actually minus 4. So you get 3 marks for this one. Are we still together, guys? Now, last one but not least, we want to get the coordinates of C. Let's look at C then. We want to get the coordinates of C. If we want to get the coordinates of C, now, E is not the midpoint, okay? E is not the midpoint. And then if E is not the midpoint here, I need to come up with a way which you say, well, how am I going to get C? Now, I'm going to get C by using the following principle. Look at this. I know what is the equation of this line. The equation of this line, it says which, give me the equation of this line. Can I say what? It's 5.
4y.
It's 4y minus 5x minus 30 is equal to 0. Okay, here's the other thing that I also know. I know the equation of this line. We just calculated it. You remember that? Okay? When we calculated the equation of this line, we got it as y is equal to minus x plus 3. Still remember that again? Now look at what is happening here. What is happening here is that the two lines are intersecting with each other. If the two lines are intersecting with each other, it means the x value of this line and the x value of this line are exactly equal. It also means the y value of this line and the y value of this line are going to be equal. So I'm going to use that into my advantage. If I use that into my advantage, then this is what I'm going to have. I am going to say, okay, this one and this one, they are equal. Simultaneous equation. If I'm going to use simultaneous equation here, I am going to say, but this one here, I can call it equation y is equal to minus x plus 3. I'll call this one equation number 1. And then this one here, I have 4y minus 5x minus 30, which is going to be 0. I'm going to call this one equation number 2. Now, I am going to sub 1 into 2. I'm going to sub 1 into what? Into 2. What do I know by that? I get this one is y here. One thing that I know is that the y of this line and the y of this line, they are equal. So yeah, when I see y with this equation here, I am going to come and substitute this thing here. I get this y here. Can you see this y here? So I am going to have 4 instead of y here. What am I going to put? I'm going to put minus x plus 1 plus 3. And then after that, it says which I am going to have minus 5x again, minus 30, which is going to be equal to what? To 0. Then from here, I'm going to remove the brackets. If I say this one multiplied by this one is going to give us what? Minus 4x. This one multiplied by this one plus 12. And then I have minus 5x minus 30. Are there any like terms here?
Yes.
Okay, give me the like terms. What are the like terms? Okay, if you have these two, what are you going to get? Then you have minus 9x again.
Yes.
And then if you say this one and this one, what do you get? It's negative 18 again. So you have minus 18, which is going to be 0. You want x, guys. How would you get x? You are going to take 18 to this other side again. And then it says which is minus 9 is going to be equal to 18, positive 18 again. You're going to have positive 18. Okay, you divide by -9, you divide by -9. It says which x is going to be equal to -2. Let's come and check it. Does it make sense for x to be -2 here? Makes sense, okay? Okay, we got x. We got x. After getting x, we're going to take this and substitute it on equation number 1. According to equation number 1, we're going to have y is equal to. Guys, we did this when we were doing simultaneous equation. You remember? Okay? It's not the first time we do simultaneous equation. So we're going to say we have y, which is going to be minus open bracket. We know what is our x, okay, now. What is our x? -2 close bracket. Plus 3. And then it says which y is going to be equal to? It's 5. And then therefore, we should coordinates is going to be -2 and 1 and 5. And then this is going to be your activity then for today. Yeah, we're going to do the following as our activity. We're going to do the following as an activity, but